Hey y'all, what's going on? We're here with a coding tutorial series to specifically answer the question, how can I persist my Redux state using some kind of API? I have a student in our full stack development bootcamp working on their final project. It's an in-browser called idle clicking game, where you basically select some options and it will go through and basically play the game for you. It's a genre of gaming that's actually pretty cool, like idle games and things like that. And it's a fantastic and killer final project, and they were wondering how to persist their Redux state as they're using Redux Toolkit. So obviously, if you don't know anything about Redux or Redux Toolkit, this may be a little over your head, but nevertheless, hopefully it helps somebody out there. And it's a cool video for me to learn something new and try and figure out solutions to it, right? So beginning here, I'm going to go ahead and get my project going, and we'll talk while some things install. So npx create react app, we'll call it persisting redux. So, you know, I came across solutions out there such as like, oh, just serialize it and cram it in local storage. But, you know, the student was like, okay, that's fine and works. But what if I, for example, one of my friends using this game has some progress and they happen to just clear their browser cache one day? I don't want them to lose all their progress. And then this individual couldn't find any solid answers out there. So that's why I did some digging around and decided to make this YouTube series around it. This video will be longer than the rest because we're going to be building out our boilerplate that I'll push to a GitHub repo that should also be in the description of this video. As a starting point for some of our different solutions to this problem. So we're going to have to write out all this boilerplate first and test it, and then I'll show you my first solution in this video, which is not very much of a Redux-y solution, but it does work. So persisting should be persisting. It's gonna bother me if it's spelled wrong. So persisting Redux. There we go. Let's fix that typo first thing and foremost. Otherwise, I'll be losing my mind trying to remember what I called the project. Okay. You know, and the local storage solution, again, I've used it before too, and I didn't mean at the time I was building like a character building application for a TTRPG for my friends and I didn't Google anything about how to persist Redux state. I was like, well, if I can just subscribe to the storage changes, I can just JSON stringify them and cram them into storage and call it a day, and it worked. And then I realized that's what everyone ends up doing, so I was glad to know that what I thought was a hacky solution worked. But then also, you know, when my student asked about how do I take that and make it asynchronous to work with an API, I was like, that's a good point, because you'd also have to worry about this on React Native apps, because y'all know that you use something called async storage on React Native applications. But anyway, let's go ahead and install a couple things to this project. I'm actually going to be building a very simple Express server. You don't know much about servers, it's okay. You can just focus on how I make network requests with fetch to this server. But I'm going to install NodeMon, Cores, and Express to build an out. For the front end, I'm going to need a Redux toolkit and React-redux to tie it together. There we go. These are going to be the installations I'll need for this little starting point of our boilerplate. There we go. I'm going to open up my code editor and bring it to this monitor because it's on the wrong one for some reason. Expand it and probably have to zoom in so y'all can see. Okay. I'm going to go ahead and create and test the server first thing. So what I need to do to build my server, it's a very simple file. I put it in the root of my project. It's not going to be very robust. Again, I could also just like make delay promise functions on my React code and to fake and simulate an asynchronous fetch request. But I've noticed when I do that for some of my more newbie students, when I do examples like that, sometimes they can go over their head of how it actually looks and combines with a real fetch request or network or Axios or whatever you end up using request. So I'm going to make this a bit more robust of an example, but not too complicated. I'm not building out a database and schema and SQL and things like that. We're going to simply use a global variable to save and store our React Redux state. So let's bring in Express. Can't wait till we have a version of Node in LTS. Stop it. Typing and talking is hard, everybody. So I can't wait till we have a version of Node that just has import statements and the module is freaking figured out finally, so I don't have to keep jumping between these two things and types of statements. We're going to need cores as well. Cool. We're going to say, let's create a new Express application, a new server. This app needs to use Core, since it's going to be running on a different port than our React application. It needs to use a body parser of some kind, whether you choose URL encoded or JSON, doesn't really matter. I'll be using JSON in this example, so in order to parse and create the rec.body, you gotta have body parser. And we're going to listen on port 8080 so it doesn't conflict with React's default port of 3000, which again, even if I ran this at 3000, create React apps code is good enough to pick that up and say, do you want to run on port 3001 instead? In this console log, I always like to give myself a nice message. Server listening on port 8080 exclamation point to feign excitement. That's a very simple server here. It's going to need a couple of routes to do its job. I'm going to go ahead and just make this dumb variable called saved state. We're going to initialize it with the value of null for now, and we're going to go ahead and make 2 requests. A get request to /state that will have the rec and response callback function is going to do a magic thing of a response JSON of the save state. This is going to respond with whatever state we're trying to save. This way we can configure our store with some saved state, some kind of preloaded state asynchronously. And we have to have a way to actually save this at some point, so I'll make this a post request at the same path. There we go. res.json state save, some kind of response that we can just Google, or not Google, console log for ourselves in the future. And it actually needs to save this state with this magic method. Like so. There we go. That way I'll make a copy of that rec body object. I don't ever recommend messing with the request body directly, so I always like making copies of it and doing things like that. So basically I'm just reassigning that save state variable globally to whatever my rec body coming in is. So I'm assuming the request body will have the correct state structure, and I can also now retrieve it from that get request. A very simple server, but it serves a particular purpose. In our package JSON, I'm going to come down yonder and add a server script that will start using nodemon on server.js. So if I do have to make any changes to my server, it should auto restart. And while we're here, we're going to add a proxy line that will actually do something for us later on. Localhost :8080, and I think because of this I don't need cores, but I like to add it there anyway just to be safe. Cores is cross-origin resource sharing. It's saying that if browsers have this coded as a default blocking feature, saying if a server is in a different location than your client website, that is called a cores request or cross-origin, because the origin of the website is not the same thing as the origin of the server, and they will clash. The browser will block that automatically. But we have cores enabled on our server, so we don't have to worry about that here. I'm going to clear this out, and I'm going to open a second window because we need one to run our React application and one to run the server. I'll run the server since it's going to be very simple up top in a smaller window. npm run server. Booyah. Cool. Listening on port 8080. Nothing to it. My server is incredibly simple in what it does. It has 2 requests at the app level that simply read and reassign a global variable, so I know once I restart the server, the global variable is not actually saving anything. This would be obviously replaced by a more robust server that you're using or coding yourself, and you would probably have a database query using Mongo or SQL or something like that. This is just for demo purposes. I'm not getting that far into building a full stack application for this example. I'm going to go ahead and open up Postman. Postman's a server testing tool. I recommend that y'all get and use it or some kind of other tool. There used to be one called, what is it called now? There are in-browser ones that you can also use. As a matter of fact, there's another one called hopscotch.io that is a simpler version of Postman that runs in the browser. So that's another option should you choose to use that as your testing tool. They work the same fundamental way. You open tabs that can simulate network requests to a server. These actually also, because they're considered server to server, don't trigger CORS requests. So localhost :8080 /state gets our state variable, which is currently null. A copy paste to a new tab, drop down to post. We're going to do a body of JSON format, and this JSON will be an example Redux state. Let's have a Redux state that has 2 reducers. We'll have one reducer called auth and then one called count coming up here. Auth will have a singular property called logged in, whose value will be false. And count will have a property called, I keep forgetting the double quotes, value of, say, 5 or something like that. Who cares? This is just test stuff, right? So that is my JSON body. If I send this request, state has been saved. If I get the state, booyah, we're now successfully have written a server that could, as long as the server doesn't restart, it saves our Redux state and then sends it back. for one singular person in their app. So if we had multiple users, clearly this is not going to work. Again, why I'm mentioning this is a contrived, what's my favorite word, example. That's it. Okay. Job here is done. Beautiful. Okay, now we're going to have to code out some boilerplate, and even with Redux Toolkit, there's still a little bit of boilerplate we have to write out. I'm actually going to remove some of the default boilerplate included with Create React App, just so I can really focus in on the fundamentals of what we actually need to get this job done. All right, and like I said, the future videos won't have this part in them. I'll have this probably pushed to a repo, so we all have like the same starting point. We can all experiment and figure this stuff out. So, okay, I have two folders, one called features, one called store, or you can call it app according to the Redux Toolkit docs. It's a folder, it doesn't matter. You can call it pizza, it doesn't matter as long as the path is correct to it. Two features. We're gonna have one called auth_slice. It's gonna have the following: import. What are we importing? Called a function called create_slice from Redux Toolkit. It's brilliant stuff. We're gonna go ahead and we'll make an initial state variable. Why not? I like doing this personally. Keep things. This will represent my auth state, and if you recall from the JSON body I was building in Postman, it was auth.loggedin. False. That's the initial state, and now we can actually create it. Auth_slice equals create_slice object argument initial state colon initial state, little ES6 shorthand right there. If the property and value are the same, you can put them together. We need a name for this state called auth, and we need to have our list of reducers as an object. And here we go. For auth, we're going to have one called a login. Login will be a function that takes the current state of auth and simply modifies it as such. State.loggedin equals true. And then we'll have one called logout that will simply set toggle it to false. And again, if you're not familiar with Redux Toolkit has a middleware applied to it called Immer, I-M-M-E-R, that allows us to write mutating code, and it will translate it into the correct the correct type of code, which is that non-mutating, like spread operator, nested spread operator garbage you have to write in vanilla Redux without Immer. It's very nifty, folks. It's super awesome. So create_slice has two things it can produce for us: a list of actions and a reducer. I'll choose to do it this way: export default the reducer from auth_slice, like so. Then from the actions, I will export out login and a logout from actions, and we'll have them be named exports. And this actually follows a pattern called Redux-Dux pattern, where you export your action not your action objects, but your action creator functions, which is what these are, and your reducer is the default export from this file. Redux Toolkit follows that Dux pattern beautifully. So I'll make the same thing for countslice.js, and to make our lives easy, I'm simply going to copy and paste some code over. I mean, why not? Let's rename this from auth_slice to countslice. The state will go from a value, or for logged in, to value, starting at 0, and we'll have some different reducers. We'll have add, which will take the current state and an action, and it will simply say state.value plus equals action.payload. So we can pass in a number to increment this value by, this count value by. Copy paste. Sun evidently. Sub minus equals action payload, and then we'll do one called reset just for funsies. For practice, state, I'll simply say state.value equals 0. There you go. There are our lovely actions, creators, so we'll add them to our list here. Sub and reset. And there we go. That is how fast and easy it is to get up and running with the Redux Toolkit. I freaking love it. Typo there, that semicolon doesn't need to be there. Okay, cool. So our two slices, that's enough slices, are done here. Sorry, I had to throw out that meme. I couldn't help it. Get in the comments if you know what I'm talking about. Throw out our store here, index.js. We're going to import. We can do it one of two ways. We'll do a configure store, like so, and we need to bring in our reducer, so I'll import auth reducer from the features directory /auth_slice, and then change this one to be the count reducer from the count slice. And you know, with a vanilla store, we can do it as such: const store equals configure store, and it needs to have our object with a property called reducer that will be an object of our two reducers, right? So this is actually something very nifty that you can do in Redux toolkit, you don't have to combine the reducers, because if you simply pass it a property called reducer with the object of your reducers in it, it will auto combine reducers for you, which is super freaking cool. If y'all recall, this is what it actually used to look like. If you have previous Redux experience and you're wondering how this is it combine reducers? It should be combine reducers. Hold on, I was hoping it was plural. I knew that. Where you do something like this: const root reducer equals a call to combine reducers. There'll be an object that will be this right here as well, as a matter of fact. Paste like that. And then in place of reducer, you'd have root reducer. So we're gonna leave it like this for now, just so, you know, some old heads can take a look at it and be like, oh yeah, that makes sense. That's what it used to look like. All right, there we go. We built out our store. It's fascinating, I know. Moving on. In our index.js, I now need to import that store from the store directory and its index file. We're gonna import our provider component from React-redux, and we're going to wrap our app in it. And it's so hard not to talk about every little thing I'm writing, because I'm actually making and still working and learning and building a React course here at Covalence that covers all this stuff incredibly in-depth. So if you have interest in that, check out the description below, go to our website, sign up, or at the very least, get involved in our Discord community and come hang out and ask questions and code and learn and ask for project ideas. At the very least, do that. So there's our provider, there's our app. Matter of fact, I don't have an app, I deleted it. So let's go ahead and bring that back in. Again, thank you for staying through the setup portion of a video. I don't like having too many things coded out beforehand in a video, because there's so many good learning opportunities coding stuff from scratch, even if I'm just kind of rambling while I code, like while I write out some boilerplate code. But this should be our app, and it should be able to access the use dispatch hook and the use selector hook. And oh my god, these hooks are so much nicer than the old connect API. If y'all remember what that looked like, get in the comments if you remember that hot mess back in the day. These hooks make our lives so much easier. I'm gonna destructure auth and count. This is also a terrible selector. If I catch y'all doing this in the real world, I'll kill ya, so don't do it. That's a terrible selector, because that means anytime any part of the global state changes, the whole ass app is going to re-render. But as we know, that's not really in the scope of this discussion. It's more about how we persist state, right? Let's do count.value. If that appears in the H1, I know we are set up and good to go. Let's go ahead and start our React app. That was a lot of code to write without actually testing, Luke, so this could lead to utter disaster, like it did in a previous take of this video series. Okay. That's what I'm talking about, y'all. Woo! We got a beautiful looking React application right here, up and running with Redux already added to it. When I was a fresh bootcamp graduate, if you told me I could get Redux like applied and up and running into a project in a span of like 5 to 10 minutes, I would have called you crazy with the old vanilla Redux boilerplate code, which I know how to write from scratch now because I have a course built around it. So this is awesome, right? We are good to go to start doing some fun stuff in the app here, like we'll say count like that. We'll div with some buttons below. This button will say add. It'll have an on-click event that when the button is clicked, it will run this function code to dispatch a adding action. We need to import that action from the appropriate feature file from features counterino, and it will have the add sub and reset features, because why not make this a little bit more fun? Paste. This one will be sub. This one will be a reset. We'll call our action creator reset, no payload required. We'll call our sub action creator with a payload of 1. We'll subtract 1, and then add will, you guessed it, add 1. There we go. Up and running. Oh, just kidding, right? An immer producer returned a new value and modify its draft. What have I done, folks? Boy, dispatch, add 1, sub 1, reset. These are all fine. It's the reducer I messed up, isn't it? Is it now? Well, what has your boy done? Is there some kind of weird, I think it's because of the implicit return is my guess. Ein Minuten bitte. Since I did one-line implicit returns, I bet it was, the immer was producing something weird because of the return. Because with immer, you can actually provide a return statement and actually use like old school syntax, where if you had something that looked like this back in the day, you would have return your state spread out, and then value would be whatever it currently is, which should be state.value minus, action.payload. This is like the type of reducers you'd have to write back in the day. I'm wondering if, because I did a implicit return on some of these code bases, that it messed up in that regard. So, okay, I'm gonna laugh that was the case. So my shorthanding is what screwed me. Yep. Okay. Yeah. So that's what it was, folks. And again, I don't like to edit out my mistakes. I like to leave them in because I think it's a valuable learning opportunity to say that someone that's done this for a long time and built a lot of projects with it, you never stop making errors, guys and gals. You simply get better at finding out what you did and how to fix them. So ES6 shorthand has screwed me in this regard, where the implicit return from the arrow functions, maybe some of y'all are already screaming at me when I was doing that, was triggering immer to not work the way it was expecting to. So there we go. Nice little fix up, right? And so I know this is just trivial, ridiculous things. I'm gonna put a fragment in here real quick. And we're gonna make the same thing for auth. Again, I wanted to have like something that was a bit more than just like a counter going up and down. So let's have a logged in. We need to actually visualize this. It won't render Boolean value, so I'm gonna actually call a toString on it so it renders the Boolean value. We'll have a login button and a logout button. We're gonna delete that button. Need to have the action creators from auth slice. Log out. Nope, not console log. Login, logout. Login. And this one will be log out. Surprise, surprise. All right, this is what I'm talking about, y'all. Okay, and again, here's our lovely app. It does so many cool things. Isn't that right, y'all? So now the question is, how do I persist this state? But honestly, before we persist the state, I think I should probably push it to a GitHub repo. And again, I know this is kind of long, but like I said before, I like having things written. I'll stop the server for now. Come on. No, whatever. New repo. We'll call it Persisting Redux Starter. Create repository on my other monitor. There we go. Initial commit. And push. Okay, so that way we'll have this in the video description. And rerun our server, so we're back up. Okay, so now this demo is actually going to kick into effect and do something. As you can see here, we need to be able to import our store synchronously and apply it as a prop to our provider component. You can actually provide some initial state to your Redux stores by utilizing a particular object key on the configure store. You can find this from the documentation on Redux Toolkit very easily, and it's called preloaded state. Preloaded state is actually very smart in that I can provide a object and it will properly merge it into my state as long as the properties are the same, right? So if I now configure this store with a preloaded state, check it out, it goes to 10. This is what you would do basically if you were using local storage. You would simply say retrieve from local storage the stringified state, and then you'd parse it and then simply tell it to use it as a preloaded state. So that's fun when you're doing something synchronous. And then this is where my student ran into trouble going, well, how would I tell it to wait in some form or fashion before rendering the app to finish retrieving that state to create the store in order to render the application? So the first solution is not really a Reduxy one. This is something I came up with basically on the fly almost instantly because I was like, oh, just wrap that shit in a promise, homie. And it's a really hacky solution, but it does work and it does have some drawbacks. So this is the first solution. It's a hacky one, but it will get the job done and will look like kings and queens doing it, right? So, yeah. What we need to do is have some way of fetching that data first and then, and then configuring our store with it. Because that preloaded state bit, the configuration must be synchronous, so it's not like we can say, hey, await this promise, then build the store. We still have to access it in this file somehow, so here we go. What I ended up doing that I called a super hacky solution I thought was quite funny, in that we're basically going to build a configure store async function that slows things down. For now, let's check out what I mean by this. I'm going to go ahead and say the following. Let's test something first. So remember when I said write that proxy line into our package JSON? Let's remind ourselves, since that was like 22-ish minutes ago, that I wrote this proxy line right here that is the address of my server. This way in my fetch request, I don't have to write the full address, which is localhost :8080/state. It will simply proxy to that value for me. So let's see if this works here. Our JSON, and then we should have our preloaded state saved from our server, but I restarted the server, so I know it lost it. So we're going to test something here, shall we? We'll console log preloaded state to see if anything fires here. I'm not going to do any crazy error handling. Not going to worry about that. So let's take a look at our apps console log. Null, that makes sense because currently it is null, right? This is what it's retrieving in its fetch request. So what we're going to do is post with our new state right here. And it's going to save that state. I'm going to confirm in our GET request that it's there. Now, if I refresh the browser, it's going to get that new state, and voila, we now have it, and we need this to be their preloaded state. So we have to have some way of wrapping the configuring of the store and accessing it still in our root of the application. So here we go with our fun utility function. I'm going to say export const configure store async. And this is going to be a function that's going to return a new promise. I teach my students how to do this to build database query utility functions, and I am amazed at how many things it can actually help. So it's going to resolve or reject with some code. What it's going to do is it's going to run this fetch code right here. I'm going to cut and paste. There we go. And it needs to configure and then resolve with the store, right? That's what we're going to have to do here. So what I am going to do is, yeah, I can do that. I can just say like, let's store equal null initially. And when the store is built, I can simply say assign a value to the store asynchronously called configure store. Surprise, surprise. Actually, it's going to do this right here. I'm just going to cut and paste. There we go. And there we go. It will configure the store with some preloaded state. And we'll use ES6 shorthand there. There we go. And now after the store has been correctly configured, we can send it out of this promise to use elsewhere by simply resolving with the store once this task has been completed, right? That's all it needs to do. So now that is set up, I can import and use it in the root of my project. And here's how we're going to do it. Like I said, hacky and fun. That's what I'm all about. That's what I'm all about, y'all. From the store, there we go. So if you didn't know you could do this, I mean, you could technically delay the initial render however you like. So bear with me. What we're going to do is simply say configure store async. When that promise then fires, it should return with our configured store asynchronously, at which point I would like to then render the app with the provider and the store asynchronously. So again, I came up with this fairly quickly, and then after doing some Googling, I found out that other people also came up with this solution, but they're like, it's kind of new, amateurish. It's not amateurish, it's good stuff. It's kind of like hacky and not very Reduxy in its implementation, but it crashes. Cannot read properties of null. Why did that happen? The state is, oh, because it reset. Yeah, so whenever I think one point in time, when I change some code in React, like a root project or a root file, I think that triggers my server to restart. So clearly, you're going to have to write some error handling, which I can do here as well. State saved, refresh. Yeah, so my server got restarted, which means my variable got reset, which means it had no initial state, which means it crashed. So we're going to have to handle that error, and I'll do that in this video. But there you go. Watch this. If I change this in my save state from 5 to 10 and from false to true, save it, refresh the app, and then initial render will come with that preloaded state. So you clearly want to have some kind of loading render happen initially that will then be kicked off during this process. If you all want to see how to do that, we can actually do that from our HTML file, where we have like an event that we fire off from here telling it to stop loading or something like that, right? But nevertheless, this is an easy way to now asynchronously preload your state from an API, all in one little nifty, tidy video. So if I was going to try and handle some kind of error, right? Like meaning if there is no store If there is no preloaded state, then I don't want it to crash the application. Here's how we could do that. I could have something like const options equals an object where I have my reducers is my root reducer. So basically I'm building this yellow object right here like this. And I'll simply say, if there is preloaded state coming back from the server, meaning it is not null, then I would simply say options.preloaded state equals preloaded state. And now I'm configured with those options in case there aren't any. And reducer is a required argument. Oh, it's reducer. Typos, y'all. There we go. So my server restarted again, so I'm going to send this, state saved, refresh, voila. I'm now going to, what am I going to do? I need to trigger my server to restart. So I'm going to restart my server like that. Now my state should be back to null, right? Get, send, it is null state. That way, if I refresh the page, it doesn't error out and crash anymore in case there is no save state for this particular user if they're making this fetch request with a token in all reality. So yeah, that is what I would do to configure my store asynchronously to get this stuff done. It's pretty cool, y'all. The next question would be, how do I actually save it in real time? This is actually another fun little solution that you can do. We're going to do an export const. We'll call it, how about we say save state? Makes sense to me. Bada bing, bada boom. It is going to be a lovely, another thing that returns a new promise, like so. It's going to have our resolving and rejecting functions. And we don't even use reject. We can ditch that if we wanted to, but I'm just trying to be consistent here. It's going to be a fetch request to /state. It is going to have some values inside of its options object because our method is no longer a get request, it's a post request. It needs to have some headers since we're sending some kind of rec body with it. The application /JSON content type header kicks on our body parser express.json, and the body will be a JSON stringify of whatever state we pass in. We're going to have that be our argument. So we're going to say that this thing's sole purpose is going to be to help us console log and see. Console log and see what we're doing here, so we can say I don't know, dot then we'll call it res. I mean, it doesn't matter what we call it, it's just a variable name, y'all. So we'll call it resolve res, like that. There we go. That's it. What its purpose is going to do is it's going to take this state and kind of save it for us to our server asynchronously, so we can keep our index code looking a bit cleaner as well. So I'll say bring in our save state. Yeah, I should probably call it async. Technically, it's a better name. That's what it's also doing, right? That's a better name, right? That's a better name. Better name than something like pizza or pasta, which is just as valid of a variable name. And while we're here with the store, because we are accessing our store here, we now have access to all of its methods, which you can dispatch functions to it, or you can even subscribe to state changes. And we can pass a callback function that will allow us to use some async await. I shouldn't really mix syntaxes of async await and dot then. I tell my students to be consistent. Who likes being consistent? But we're going to pass it a callback function that will then run our save state async function, passing in the store state, which we can access by running a store.getState call that will get the global state of the store synchronously and return it to us to our save state function that will then take whatever response our server sends back to us and console log it, which, if you remember, was that message that said state saved. So taking a look at it now. Okay, seems to be working just fine. And even if I do empty cache and hard reload, our server has the state of the application or this user in a database somewhere saved. We would then retrieve that information and then be able to asynchronously preload our saved Redux state. Other solutions that I'll be talking about will be how can we do like some HTML handling if we needed to, how we could use a library like Redux Persist, which had a large gap where it wasn't being maintained. So if you see any answers using that library from a couple of years ago, they will fall a little bit short. Thankfully, in 2021, I saw in their GitHub documentation that they got some new maintainers, like new management is what they called it, and they actually added TypeScript to it, thank God, and it's pretty awesome. I'll be covering that in a video to show you how that works there, and I'll actually show you another way to do this with a more Reduxy solution where we'll have an app simply run a use effect that will dispatch an action to try and hydrate our store, is a term you're going to get used to hearing as well. That's hydrating the state, right? Filling in values from before. And yeah, that's we're gonna end this video here. It's already 34 minutes long, but this is a fine solution. Like I said, it's a little bit hacky and not very Reduxy in its implementation, right? Because we're kind of not working with what Redux is supposed to be, which is everything is dispatched to the store synchronously. We're kind of handling that weirdly. We'd have to error handle or loading handle our initial render somehow to let our users know something is happening in case our server or their internet connection happens to be particularly slow that day. We'll have to account for that kind of stuff as well. But yeah, this totally works, and it's what I recommend y'all start with if this is what you're trying to figure out how to persist state. Yeah, so I mean, check the comments below for the GitHub repo if you want this boilerplate as a starting point for practicing or doing things in general. If you have comments, questions, or concerns, obviously like, comment, subscribe, right? Get in there, get in the comments, let us know. Follow the link below to covalence.io to sign up for our React course. If you're just here totally curious, we have a full stack development course as well, and I chill in our Discord pretty regularly, whether it's on hours or off hours, because I just like helping people and I like coding and I like learning stuff, and there's no better way to code and learn than to work alongside with students at any skill level, above mine, below mine, equal to mine, doesn't matter, because we all can help each other on this journey that we're all on together. So ta-ta for now. I'll see y'all in the next video where we'll talk about a different approach to trying to save your state.